Okay, in this video we're going to be looking at finding the highest or lowest common multiple and highest common factor of three numbers. We're going to use prime factorisation for both of these, so you need to know what we mean by lowest common multiple, what we mean by highest common factor, and how we do prime factorisation. Okay, so let's get started. We need to find the highest common factor and lowest common multiple of 15, 80, and 50. So the first thing we're going to do is our prime factor trees to write each of these as a product of their primes. So the first one is really straightforward. 15 is, well, that's 3 times 5. 3 is a prime number and 5 is a prime number. So 15 as a product of its primes is just 3 times 5. We don't even have any powers there or anything, that's fine. 80, next up. You can go about this, you could halve it if you wanted to. I'm going to divide it by 10, so that's 8 and 10. 10 is 2 times 5. They're both prime. 8 is 2 times 4. And then 4 is 2 times 2. So 80 as a product of its primes is equal to 1, 2, 3, 4 lots of 4. Well, 2 to the power of 4, 4 lots of 2. 4. So it'd be 2 times 2 times 2 times 2 is 4 times 5. Don't forget you can write this as 2 times 2 times 2 times 2 times 5. And then lastly, let's do 50. You could do this how you want. You could do, let's do it by 10. So that is 10 times 5. 5 is a prime number, so that branch stops. 10 is 2 lots of 5. Both of them are prime, so both of them stop. So 50 as a product of its primes is equal to 2 times 5 squared. Do not forget, this can be written as 2 times 5 times 5. Right then, so normally you would draw a Venn diagram with 2 circles. This time we have 3 numbers, so we're going to have 3 circles, okay? So we're going to have a circle for 15, a circle for 80, and then a circle for 50. So we're going to write all the things that all 3 of them have in common in the middle. The thing that 2 of them have in common we'll write in this gap, and then the thing they have on their own we put on this. So we're going to fill this out with all their products of primes, okay? So first of all, we're going to have a little glance across. Is there anything they all share? Well, they all have at least 1 5. So that means let's take the 5 and we can put it in the middle here. Okay, is there anything else that all of them share? Well, these 2 have got a 2, this one hasn't. It's got a 3, these 2 haven't. This has got another 5. Neither of the others have. Okay, so we can fill out the rest now. We've got the thing in the middle, that's fine. So 15 has a 3. None of the other numbers have a 3, so that means 3 is going to go on its own in here. We've done that. 15 is sorted. We don't even have to worry about anything in that circle anymore. 80, let's have a look. So we've got 2. So there's a 2 in the 50. Okay, so we're going to take that 2 and put it here. Okay, let's just think about what this means. Okay, so in the circle of 80, we've got a 5 and a 2. And in the circle of 50, we've got a 5 and a 2. All that's saying is 5 and 2 are both factors. Well, what does that tell us about them 2 numbers? Well, 5 times 2 is 10. That tells us they're both in the 10 times table, which is correct. They are both in the 10 times table. So where are we with this? We have done our 2s that they both share. We've done our 5 that they both share. This has 3 more 2s. That doesn't have any. So let's put a 2, another 2, and another 2. This one has 5 here. That's the last one. Okay, so let's do highest common factor first. So the highest common factor of 15, 80, and 50 is, well, it's everything that's in the intersection. So what is in all 3 circles? So we're talking about this area here. So you would multiply all the numbers in there together. In this case, there's only one number. So the highest common factor of 15, 80, and 50 is going to be 5. Now let's have a look at lowest common multiple. $15, $80, and $50. Okay, so we're going to have to times everything that's in them circles together. Okay, now it still works exactly like if you had 2 circles, okay? We have only written the 5 once when it appears 3 times, and we've only written one of the 2's once when it appears twice, okay? So this calculation will have less numbers in it than all 3 of these added together, and then it should hopefully give us our answer. So let's multiply together everything in these 3 circles. So let's start off with in our 15 circle. So that's 3 times that 5. Okay. In our 80 circle, so we've got 2 times 2 times 2 times 2. We've already written that 5. 2 times 2 times 2 times 2. We don't need to worry about a 5 because we've already written it down. And then in your 50 circle, we've written this 5 and this 2 down already, so we've only left with that 5. Okay, so just double check we've got the same amount of numbers here as there are in that Venn diagram. So in the Venn diagram, we've got 1, 2, 3, 4, 5, 6, 7 numbers. And down here we have 1, 2, 3, 4, 5, 6, 7 numbers. Okay, good. So hopefully we've not gone wrong. Right, so let's do a little bit of manipulating these to get an answer. So let's bring our powers together. So that is 2 to the 4 times 3 times 5 squared. 2 to the 4 is 16 times 3 times 5 squared is 25. 3 times 25 is 75, so 16 times 75. I'll do a quick Napier's method to work this out. So we've got 1 and 6, 7 and 5, draw our grid. Six times 7 is 42, 6 times 5 is 30, 5 times 1 is 5, 7 times 1 is 7, add this up is 0, add this up is 10, add this up is 12, 1 add 0 is 1. So that means our lowest common multiple is 1,200. Okay, so that's how you'd go about doing it with 3 numbers. It works exactly the same, it's just our Venn diagram has 3 parts. We have to be careful when we write our numbers out here because some may be shared by 2 and not by the other. Other than that, it works exactly the same and you can do it.